We're starting to talk about vectors, a very important topic in both math and science, mainly because vectors have two things that they deal with, direction and magnitude. Magnitude is just another word for size. An example we talk about is velocity. Velocity is an example of a vector. It has a direction, positive or negative, so if your velocity is like, let's say, negative 9 meters per second, this is telling me its direction is going backwards and its speed 9 meters per second. So it has two things. We're going backwards, that's direction, and speed 9 meters per second. Whereas a scalar quantity has no direction. It's such as volume or speed. So example, if I didn't have the backwards, like this 9 meters per second, that would be a speed. Now, what does a vector look like? Well, we have to start somewhere. We have some initial starting point, an initial point. Where are we starting? We have to head off into some direction, and we're heading to some, what we call a terminal point. Okay? Now, if I think of this as, from my initial point to here, if I think of this as like an a coordinate axis, here's being my x-axis, here's being my y-axis, I can use this to find direction. In other words, the angle, and we're going to talk about that tomorrow. And we can also use this to find magnitude, which we're actually going to talk about today. And we call this the magnitude of the vector. Now, when we're talking about a vector, we use this little symbol right here. It's called a hat. Now, we don't need to really write these symbols for right now. Those symbols right there are what we call the magnitude of the vector, its length. So we have a vector going at a certain angle, and we can measure its length by using, of course, right triangles, Pythagorean theorem. So what exactly is a vector? A vector is what we call a directed line segment. In other words, it has a start and an ending point, an initial and a terminal point. Two vectors are equal if they have the same length and go into the same direction. So they don't have, so I can have two vectors, just for example, here's a vector, and here's another vector. They're both the same length, they're both heading up in the same direction, so we call them the same vectors. So, and this is really important because we don't have to write these in the same place. We don't have to draw them in the same. There are many ways we can write a vector. One is what we call the component form of a vector, and this is one of the easiest things to do. You can read all of this as you want, but basically to write a vector, the most important thing is here, it's called V, and we actually have the name, it's called V hat. It means it's talking about a vector. All this basically says to do is you're going to take the terminal minus the initial. Okay? So, if I want to write this in component form, it's very easy. Okay, we're going to talk about these symbols in just a few moments. It's very easy. If I look at vector V, I look at its initial point. The initial point looks to be at negative 6, 3. The terminal point looks like it's at negative 4, 7. If I want to write this as a vector, I'm going to take the difference in my x values, change in x, and the change in your y values. Now these symbols right here are what we call chevrons. And basically what they mean is that we're talking about a vector. If they were smooth, we'd be talking about a point, although sometimes we can use them as a vector as well. But we like to do this as we're talking about a vector. So if I find my change in x, it's terminal minus the initial, so that becomes a plus 6, terminal, 7 minus 3 minus the initial, and this becomes 2, 4. So that would be our vector right there. So, and we can take a look at it. Basically what it means is this is the change in x and change in y. I went right 2, up 4. Does that sound familiar? It should. It's our slope. And that's why we like this component form. This can give us the slope of a line. To get vector A, I find the initial point. It's at 3, negative 2. Find the terminal. It's at 7, negative 3. So to find the vector, remember, terminal minus initial. 7 minus 3, negative 3 minus a negative 2. Put your chevrons on. And what we get is 4, negative 1. And there's our vector. And what's it telling me to do? From where I started, I'm going to go right 4, down 1. It's like directions. Think of vector as being like directions. You're going to go right 4, down 1. And there we have our vector. So you guys go and try number 3 real quickly, and then go ahead and go on to the next page. All right. Now, if we know about vectors, we can actually perform a lot of algebraic operations on them. So let the following vectors be true. Let u be the vector negative 3, 4. Remember, it goes right 3, down 4. You can even graph this. Ready? If you start here, this is vector u if you want to look at it. It goes right 3, 1, 2, 3, down 4. 1, 2, oh, up 4. That's awful. 1, 2, 3, 4. So it starts here. We don't know where we're starting, so we always start at the origin. And that's what our vector looks like. That's the direction it's heading. So I can add vectors together. There's u, there's v, and there's w. So this says to take vector u, add it to vector w. And it's really easy to do. We take negative 3, 4, that's u, plus w, which is 0, negative 3. And we add them together, like parts. The negative 3 be adds to the 0, and the 4 we're going to add to the negative 3. Don't forget your chevrons. Negative 3, 1. And then they say sketch the resultant vector. So if I wanted to sketch this, think of it as directions. X, Y. This says to go left 3, up 1. 1, 2, 3, up 1. There's my initial. Always start at the middle. Initial. And my terminal is at 3, 1. Terminal. It ends. And I just draw it in there, like so. Very easy to do. Let's try number 2 here. To V or not to V? That is the question that confuses me. All right, so we go 2 times vector V. It's just algebra. All algebra has to apply. Minus 3, u, negative 3, 4. And I just simplify this. I can distribute because I am just taking my slope and doubling it. So this doubles the length. That's all it does, is it doubles the length of the vector. That's what multiplying it by 2 does. So we get the vector becomes 4, 10. So it is still going in the same direction, if you notice, because 5 over 2, slope-wise, is the same as 10 over 4. So it goes in the same direction. Minus, distribute the 3, be careful, this becomes negative 9, 12. And then I'm just going to combine my like parts. 4 minus a negative 9, 10 minus 12. And this becomes 13, negative 2. So what happens is that this vector, is the composite of these vectors, goes right 13, down 2. There's 13, easy breezy. There's 2, negative 2. Starts here, ends here. There's my terminal. There's my initial. And we're heading in this direction. Now we need the arrow because the arrow says I'm heading towards this way. I start at 0, 0. I'm heading towards the terminal point. Okay? So basically what this gives us is our terminal point sometimes. Okay? All right. Why don't you guys go ahead and try number 3. And then we're going to take a look at what we call standard unit vectors. Okay? And these aren't hard to do either way. It's just another way to look at it. Okay? Alright. So, vectors can also be written in what we call standard unit vectors. In other words, the vectors in terms of its unit length and direction. Now, we have one method we talked about which we called the component form of the vector. The other one is called a standard unit. Now, if you're in physics, that's where we tend to see this one right here. Physics, we tend to see this one. And in math, we tend to see the component because mathematicians are smart. We like to keep things simple. So let's say we're in the x direction. The standard unit. Now, when we say standard unit, we're talking about one space. We call it I. Or I hat. Now, I'm old school. I'll use I hat. In the y direction, or in a standard unit, which is one space, we call that j or j hat. So you'll see me use j hat. I hat and j hat. That's the way I do it. Therefore, a standard unit vector could be written as this. So if we want to write a vector, we could write it as this, as an example. I plus j. So this is telling me my x direction, how far we go, and this is telling me how far we go in the y direction. So examples, these will make it easy to graph though, because like graphing is very easy. The vector v hat equals 3i plus 2j. Again, I like to use hats. This is telling me my vector, no matter where I start from, I'm going to go right 3 up 2. So if I wanted to graph it, now, it doesn't matter where we start. So let's say we're given some sort of initial condition. Let's say we're starting at the point -1, 3. So I graph it, -1 up 3. There's my initial point. My vector says I need to go right from here to wind up where I want to stop. I'm going to go right 3. 1, 2, 3. Okay? That's our 3 in the I. And then it says go up 2. 1, 2. So that's our 2j. And I can draw it. There's my vector. Okay? So why don't you guys go ahead and try one real quickly. The graph the following. V hat equals, let's say, -I plus 2j. And let's let the initial be at the point 0, 0. Go ahead and graph that one, okay, right here, and then go into part 2.